All right, welcome back to Data Math Concepts. Looking at question 3, Add Math 2023, June. All right, question 3 says, it says the equation of the circle is x squared plus y squared minus 8x minus 18y plus 93 equal 0. Determine the coordinates of the center. Now, whenever we get the equation of a circle in this form, right, there are certain things that we could easily do to find the center. What is the center? The center is simply going to be minus f minus g. So now, where is f, where is g, right? So the format that we're looking at is this: x squared plus y squared plus 2fx plus 2gy plus c equals 0. So in this form, right, we are able to use this to pick up our f and our g. So in order to find the center, what we're going to do is to zoom in on that and that. So let us just take a closer look. Then from this, then, let's look at the negative 8x here. The negative 8x will be likened onto this. So I could say the 2f is equal to the negative 8. Right? So if the 2f is equal to the negative 8, then f is simply dividing by 2, dividing by 2. F is simply negative 4. Now, on the other hand, I'm going to use this part to focus on this, right? So then 2gy is equal to negative 18. No, not 2gy, hold on, 2g. Where is this? Yeah, let me write this over. All right, so 2g is equal to negative 18. Divide by 2, divide by 2. G is equal to negative 9. Now, we have f and g, right? But remember now, the center is not f and g. The coordinate for the center is going to be the opposite to f, which is going to be positive 4. So taking our negative 4 and negative 9, we're going to get positive 4, positive 9. This is our center, right? So we can always easily find our center from that sort of situation. All right. So now the next question says, find the radius. All right. So the radius can easily be calculated using this formula. It says f squared plus g squared minus c. And that will take us to the radius, right? So in this case, we're looking at f, right? Back our f, remember now, our f is negative 4, our g is negative 9, right? Our g is negative 9. So we're talking about negative 4 square plus negative 9 square, and then we're going to minus c. C is 93, right? So from that, we have 4, 4, 16 plus 81, take away 93. All right, so this is for 16 plus that, that's 97. 97 minus 93, we have the root of 4, and the root of 4 gives us 2. So the radius is 2 units. Easily done. 1 mark. Now, find the equation of the normal to the circle. So then basically, the idea. So we're looking at just the idea. So the idea is that here is a circle, right? And there is a radius, 2 units, yeah? So from the center of the circle, we have a radius, 2 units. So that's the idea. So this is like our center. Our center here is 4, 9. Just an idea. This is x and that is y. Then now, so remember the normal is perpendicular to the tangent, right? So what we're going to do here is that we can find here So we want to understand that if we find the gradient of this line, which is the normal is the radius, right? Because this idea is a tangent, even though we're not using it. But I just wanted you to see tangent normal, right? So we're finding the equation to the normal. So the normal is the radius right here. We're finding the equation of this radius. This is the normal. All right. So then all we're going to have to do is to label our points. So we're going to label the 2 points. So we have 4, 9, which is the center. We have 2, 8. So we can call this x1, y1, x2, y2. So we need the gradient. So the gradient is going to be y2 minus y1 over x2 minus x1. We're looking at 8 minus 9 over 2 minus 4. That's going to give me negative 1 over negative 2, which is 1 over 2. Right? So negative 1 over negative 2. So just make sure that there is no error in terms of what we do. Right? So it's a half. Now, so if I'm going to write the equation, then I could simply say, using y equal to mx plus c, I'm going to try to find c. Right? So there are a few ways you could do it. So I'm going to take a point. So I'm going to take any one of the points. Let us say I take 4, 9. This is x, this is y. So 9 is for the y, which is equal to m, which is a half gradient, times x, which is 4, plus c. We're seeing where we could cancel here. 2 into 1, 2 into 4, 2. So we have 9 equal to 2 plus c. Subtract 2 from both sides. 7 is equal to c. All right. So the fact that we have our c value, then we could say y is equal to half x plus 7. And that is the equation of the normal to the circle at that point. All right. Next question is actually looking at a position vector. So it said the position vectors of 2 points A and B relative to the origin O are such that OA is equal to 3i minus j and OB is equal to 5i minus 4j. Determine the unit vector. Now, the concept of the unit vector, right? So the unit vector is simply having this vector, right? And you want to put this over the modulus of this vector. So the unit vector is to have the vector and divide by the length of, right? So we're going to have to look at this. Let us put it together. So what we're looking at here is for the unit vector, we need to find AB first. So AB can be found more than one ways. AB can be found by using A to O plus O to B. We can take that route, right? So A to O is going contrary to this. So it's going to be negative 3i with a positive j. And we want to add that to OB as is, which is 5i minus 4j. So we're looking at putting together the i's. So we're getting a positive 2i, and putting together the j's, we're going to get a negative 3j. So there it is that we have the vector AB. So what we need to do now is to find the modulus, which is to find the length of the vector. So it's going to be as follows. It's going to be 2 square plus negative 3 square. And we're looking at 4 plus 9. And this is going to give us the root of 13 units. So then at the end of the day, the unit vector, talking about the unit vector AB, is going to equal to 2 over the root of 13i minus 3 over the root of 13j. There it is, our unit vector. Follow-up question says, want to find the acute angle AOB in degrees to 1 decimal place. Now, if we're going to deal with that, there's a formula that says here, if we have, so this is a general formula. So basically in this context, I'm going to write it for the idea. I'm going to say that if we have OA dot OB dot product over the modulus of OA times the modulus of OB, this is going to equal to the cosine of the angle between OA and OB. So we could find the dot product first. So we want to go to the dot product now. So the dot product is simply, in this context, I'm going to write it. So the dot product of OA, OB, in a sense, we're going to take AX, right? So we want to take AX along with, say, BX. And you want to add that to AY, BY, right? So that's the idea. So what we're suggesting is we're going to multiply so we want to go back for these vectors. Let us have them here. And OB was 5I minus 4j. All right, so let us find the dot product. So we're talking about 3 times 5, taking the two x values, you want to add that to product -1 times -4, and we're looking at 15 plus 4, and we're getting 19 as the dot product. Then we want to find the modulus of OA. So we're talking about 3 square plus -1 square. So that is 9 plus 1. This is the root of 10 units. And then OB, we want to find the mod of that as well. And OB is going to be 5 square plus -4 square. And this is 25 plus 16. And that's about 41, right? So the root of 41 right there. So then now that we have these, we can easily find the angle between, right? So let's find the angle between them. So now, so let us put these in. So utilizing this formula here, right? What I'm going to do now is that I'm going to put the dot product on top, which is 19 on top of the root of 10 times the root of 41. And this is going to equal to the cosine of the angle between them. So 19 over that, we could easily work out that. So 19 divided by root 10. We're getting at the bottom 0. 19 divided by this, hold on. 19 divided by that, I'm getting 0.9383, which is the cosine of the angle. So I'm going to have to go cos inverse. So cos inverse 0.9383. And cos inverse of 0.9383. And the angle is 20.2 degrees to 1 dp, right? Because it did say to 1 decimal place. So that's the angle between them right there. So the angle between is 20.2 degrees. All right, let's go. Final question for question 3. We're solving a trig equation. So basically, we have 2 sine 2 square, which is equal to 3 cos theta. And we're going between 0 to 180. What we want to do is to kind of swap out things. If you remember this, that cos square theta plus sine square theta equal 1, then from this we could manipulate. So we could say sine square theta is going to equal to 1 minus cos square theta, right? So I could substitute this here with that idea. So what we have on the left side is 2, and instead of writing sine square, I'm swapping out so I have one trig function working with cos. So I'm going to put 1 minus cos square theta, and that is equal to 3 cos square theta. So now I have all costs. I'm going to bring everything under one umbrella. So I'm going to distribute this 2 inside. So I have 2 minus 2 cos square theta. I'm going to bring this across. So it's going to be minus 3 cos theta, which is equal to 0. Organize this in sort of a order. So I have negative 2 cos square theta, then minus 3 cos theta plus 2 equal to 0. Could work right now. Now at this moment, I want, because I'm having this, I'm seeing a quadratic coming. So I'm going to swap out. I'm going to let t equal cos theta. All right. So I'm going to let p equal to cos theta such that negative 2p squared minus 3p plus 2 equals 0. So what I want to do now is to factorize this, right? So I want to factorize this quickly. I could just set up to factorize, right? So I have a negative 2p, and this is p. I have a 1, and I have a 2. All right. So this is going to be a positive 2, positive 1, right? So there it is. I'll be getting 1. So this is the factor. So from this, I could solve. So it's either, right? So it's either negative 2p plus 1 equals 0, which means negative 2p equal negative 1 divided by negative 2. Then p is equal to a half. Or p plus 2 equals 0. Then p is negative 2. Now, we want to remember that in the beginning, we did do some substitution here. P was equal to cos theta. So I want to sub this out. So then right here, I could have cos theta equal to a half. Also, cos theta equal to negative 2. Now, this one is a problem, right? That one is a problem because cos function between, when we deal with the cos of an angle, we get values from negative 1 to positive 1, right? So this is out. We're not able to get this. In other words, if we do cos inverse of negative 2, we're going to get math error. But the other one here, all right, we could do the cos inverse of 0.5, which is a half, and then we're going to get 60 degrees. So it simply means then we're looking at 60 degrees, right? Now, remember though, we're functioning, right? How are we functioning? We're functioning between, we want the angle theta to be less than 180, but greater than 0. So this is an option that fell in that. So theta right now is 60 degrees. Now, wherever cos is positive again, like get positive value for cos, there are 2 places. We could get that in quadrant 1 and quadrant 4. All right, so we have C, A, S, T, and that's where the various trig functions are positive. So cos is positive in quadrant 1 and quadrant 4, and quadrant 4 is between 270 and 360 again. So the thing is, we only have one answer because where the other answer is, we're not going that far. We're stopping at 180. So this is the final answer. So we're supposed to prove this trig identity. So what we normally do is just work, right? Taking the left side, I'm going to do algebra, all right? So my LCM, as you could see, would be, my LCM would be 1 minus sine square, 1 plus sine square x, right? So now, when we start working, we're going to get sine 1 minus sine square cancel. So we're going to get 1 plus sine x here. And then this cancel will have minus. And then in the bracket, I'm going to have 1 minus sine square x. So let's clear up what is at top. So at top, I have 1 plus sine x minus 1 plus sine x all over this. But when you take a look, this is the difference of 2 square. 1 minus sine x, 1 plus sine x. So this is basically 1 square, yeah, minus sine square x, right? So that's the difference of 2 square there. Now let's go. On top, what we have now is that 1 minus 1 is gone. So we're only left with 2 sine x at the top over. Now I have 1 minus sine x, but recall that we just used this for cos square x, right? So cos square x is the same thing as 1 minus sine x. So we're going to sub that now. So we're going to sub this. So this becomes cos square x. It's coming from this idea. It's coming from the idea that cos square x plus sine square x is 1. All right. So you could see where cos square x is the same thing as 1 minus sine square x. So we're taking it like that. So from this now, we could split. So watch this. 2 sine x over cos x times cos x. Now let's take a look. Definitely remember what tangent is. Tangent is sine over cos. So at top, I'm going to have 2 tan x with a cos x left underneath, because this and these up here at the top will form a tangent, right? So we have 2 tan x at the top over cos x, hence the proof, right? So right there, you're seeing where we did that, right? Thank you for watching Daily Maths Concept. See you next time. Bye-bye.